We are covering Trig Unit 1, Day 5, and we're going to learn how to find trig ratios from triangles other than special triangles. So we've done special triangles, we've done finding trig ratios from the calculator. Today we're going to look at finding trig ratios from ordered pairs. So if we have the ordered pair 3, 4, it defines a point with an x offset of 3 and a y offset of 4 in the coordinate plane. So here it is. This is our point right here. And you can see, what does that mean? That means if we drew the triangle with the hypotenuse from the origin to that point, 3 is the length of our adjacent, 4 is the length of our opposite. Just like quadrantal angles for the special triangles, the x-coordinate defines our adjacent length and the y-coordinate defines our opposite length. And the only thing we need to do our trig ratios is we need to find our hypotenuse. Since this is a right triangle, we have a right angle here, we can use Pythagorean theorem. So the square root of 3 squared plus 4 squared gives us 5 for a hypotenuse. And now we have adjacent, opposite, hypotenuse. We just create our trig ratios off of those values. And here they are. So opposite over hypotenuse, the sine of theta. And we don't know what this angle is, and we don't care, because whatever angle it is, it's going to have these ratio of sides. In the next unit, Unit 2, we're actually going to find out or figure out how to find that angle. And we did this a little bit last year using inverse trig functions. That's how we would actually find the angle. So opposite over hypotenuse is 4 over 5. Cosine of theta is adjacent over hypotenuse, which is 3 over 5. Tangent is opposite over adjacent, which is 4 over 3. Cosecant is hypotenuse over opposite, 5 over 4. Secant, hypotenuse over adjacent. And then this actually should be cotangent, which is adjacent over opposite, which is going to be 3/4. All right, so what if we have the ordered pair negative 3, 4? Well, that defines a point with an offset of negative 3, so that means you're going to go left from the origin, and a y offset of 4. This is a point in quadrant 2. So if we map that point, it's going to be right here. So this is our negative 3, 4. And again, we're just going to use this as our adjacent length. Even though it's negative, it's not really a length, but it corresponds to the x-coordinate, and this is our opposite. And again, we need to find our hypotenuse, Pythagorean theorem, and since the numeric values are the same as the last example, we're going to end up with the same hypotenuse of 5. So again, create our ratios, and they're going to be exactly the same as the ratios from the last slide, except those that use the adjacent side are going to end up having a negative value. So cosecant is going to be a negative 3 over 5. Tangent's going to be a negative 4/3. Cosecant is positive. Secant is going to be a negative 5 over 3, and adjacent, again, this should be cotangent, is going to be a negative 3 over 4. All right, so to find ratios with an ordered pair, you find the point specified by the ordered pair and find out which quadrant you're in. You find the missing side using coordinates and Pythagorean theorem. And then you're going to fill in the ratios using SOHCAHTOA and then find your reciprocal trig functions. And the reason I say don't necessarily say hypotenuse, because we're going to get into some problems where you're going to need to find a leg because you already know the hypotenuse, and we'll get to those later. So this is one that you should try. Find the trig values for a triangle in standard position, and that just means that the vertex is at the origin, whether it's in, doesn't matter what quadrant, but you can see the angles, vertex are all at the origin. So coordinates are 6, negative 8. You should try that and make sure you know how to do that. All right, so the next type of problem is this. Find the value of the other trig functions given that the tangent of the angle is negative 3 over 2 in quadrant 4. So first of all, we want to figure out what values we have. Tangent is opposite over adjacent. So that means our opposite length is going to be 3, and then our adjacent length, oops, I guess I should make that a little consistent. Our adjacent length is going to be 2. And the negative, we're going to figure out which that is based on the quadrant. So here's the xy axis. If we have the point here, which is going to be negative, 1 quadrant for our y value is negative, so it's going to be the 3 is going to be negative and the 2 is going to be positive. So you have to know which quadrant in order to figure out whether the opposite or adjacent is the negative value if you have a negative ratio. Of course, remember, hypotenuse is always positive. We do need to find the hypotenuse, so we're going to use Pythagorean theorem. And we're going to get the square root of negative 3 squared plus 2 squared, which gives us hypotenuse of square root of 13. And you will leave it as a radical, because that's going to be the exact value. It's not an approximation. And now we're going to find all our ratios. Just remember, we always rationalize. So when we rationalize this, we multiply the top and bottom by the square root of 13 over the square root of 13 to get 3 square root of 13 over 13. Again, and notice, since it's the opposite that's negative, any ratio that uses the opposite is going to be negative as well. Notice we don't have tangent because we've been given tangent. So we're going to find the 5 other values, and we just use SOHCAHTOA to fill in the values once we have our triangle. And you might want to write in your hypotenuse. All right, next example. Whoops. Find the value of the other trig functions when sine is equal to 3/5 in quadrant 2. So I'm going to draw the triangle. Sine is opposite over hypotenuse, so that means my opposite length is equal to 3 and my hypotenuse is equal to 5. So notice this time we're given the hypotenuse, and what we need to find is this. Notice 2, it's in quadrant 2. That means whatever value we get, it's going to need to be negative. So we're going to find this leg and put a negative sign in front of it. Use Pythagorean theorem. So 5 squared, our hypotenuse squared, is equal to our leg squared plus our other leg squared. That gives us 25 is equal to 9 plus a squared. A squared is 16. So a is 4, but since we're in quadrant 2, it's going to be a negative 4. And now again, we have our hypotenuse adjacent. This is, of course, our adjacent, opposite, hypotenuse. Use SOHCAHTOA to fill in the values. So we have sine. We're going to start with cosine. Adjacent over opposite, or hypotenuse, it's negative. Anything that uses adjacent is negative. Opposite over adjacent. Hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. So for these problems, you need to figure out, if you're given whatever trig ratio you're given, figure out which sides you're using. So as I did here, and then that tells me the lengths of those sides, and I will find the missing side using Pythagorean theorem, whether it is a leg or whether it is the hypotenuse. And you need to make sure once you find the leg, based on whether it's x or y coordinate, if it should be positive or negative. All right, this would be one for you to try. So find the other values when tangent is 4 over 5 in quadrant 3. And you may want a little trick or little memory tool to help you figure out whether, once you have all your ratios, you actually have the right sign in front of them, because it can be confusing when things are positive and negative. So the memory tool is this. So this says a way to remember which trig functions are positive. This tells you which quadrants a particular trig function is positive. And if you start with quadrant 1 and go counterclockwise, all students take calculus. This tells you where the trig ratios are positive. So in quadrant 1, all of them are. In quadrant 2, the S means that the sign is positive. as well as the reciprocal function, because wherever sine's positive, cosecant will be positive. Tangent, so all students take, so this stands for tangent, so this means tangent and cotangent are positive. And I'll put pluses here so you know that that's what it means. Oh dear, not very good. Okay. And then calculus, so in quadrant 4, cosine is positive along with its reciprocal, which is secant. So this might help you. All students take calculus. If you remember it and it helps you, great. If it's not helpful, you can't remember it, then don't worry about it. It's just a little trick, basically. All right, so you will have a worksheet to complete. Bring any questions to class.